Assalamualaikum. We continue with problem number 7. Solve the equation. Okay, I think I probably have enough space. On this paper itself, I don't need to transfer. Let's put it on the left hand side here. X raised to the power of x equal to 2 over 16 1 minus x. Okay, 8 is actually 2 to the power of 3. Then we raise to the power of x again, equal to 2, which is to the power of 1, over 16, which is a 2 to the power of 4, and then 1 raised to the power of 1 minus x, and this becomes 2 3x equal to 2 1 2 4 1 minus x. Alright, and next we want to put the whole thing, the whole denominator here to the top, okay, so that we can equate both left and right. So 2 3x equal to 2 1 multiply with 2 minus 4 1 minus x. Okay, I continue over this side. Then 2 3x is equal to 2 1 minus 4 1 minus x. Then 2 3x equal to 2 okay, this become x 4x, and let me just delete that. 4x 1 minus 4 minus 3. That makes it, okay, we just take a look at the power there. Then that will make 3x equal to 4x minus 3, and then x is equal to 3. Cool. Okay, number 8. Given that log 2m log to the base of 2 of m is to p, then express this one, complex one. So I do it right into this piece of paper on the left. Log 16. Oh, okay, I hope you can see it clearly. 8m squared. This is equal to I change it, the base of the log to become log base of 2 8m squared over log base 2 16m. Okay, then to become I can split log the one above, log base 2 of 8 plus log base 2 of m squared over log to the base of 2 of 16 plus log to the base of 2 of m. Okay, log 8 to the base of 2 is 3, because 2 raised to the power of 3 is equal to 8, so it's 3, plus, and this we can manipulate it to become 2 log 2m over log 16 to the base of 2, that is 4, because 2 raised to the power of 4 is 16, so it's 4 time plus log m to the base of 2. Okay, remember this. Okay, we just put it back into the equation, then it becomes 3 plus 2p over 4 plus p. So this is the answer. So if you get this one right with the right step, you get full mark, 4 marks. Okay, let's move on. Question number 9. The first term of geometric progression p. Progression is p, and the sixth term is 32p raised to the power of 6. Okay, let's do this. So we're gonna use the formula Tn equal to Arn to raised to the power of n minus 1. In this case, first term which is a, is equal to p. Okay, because it's given already here. And term number 6, the sixth term, is 32p 32p raised to the power 6. So if we put the format here, then T6 is P R n minus 1 R n minus 1, then 6 minus 1 becomes 5 is equal to 32p6. Okay, then we can cut out the p. Oh, hold on, this is not 2, this is, let me get that corrected, this is 30p raised to 6. Okay, then we cut out this and become 5. Okay, so R 5 is equal to 32p raised to the power 5. So R is equal to root 5 of 32p5. Then what is root 5 of 32? That is 2 times 2 times 2 times 2 times 2. Yeah, that's 2 then. And then of course we love is p. So that is the answer, 2p. Quite easy. Next question, number 10. Given the second term and fifth term of an arithmetic progression is 2q plus 3 and 12q minus 1 respectively. So that is the second term and fifth term. And the common difference is 2. Find the value q. So what is the formula that we are looking at? It's going to be Tn equal to A plus n minus 1d. Minus 1d. So this is the formula that we need. So d is 2, given that d is 2. Okay, then t, the first one is the second term, and the t2 is a plus d, right? Or plus 2 then, because d is 2. A is not given there. Okay, and what's next? Then t5 is a plus n minus 1. N minus 1 is 4 times 2. Alright, then and this come up to the first one, right? A plus 2 equal to QQ plus 3. And this one, well, T5 is A plus 8. Okay, this one come up to A plus 8 equal to 12Q minus 1. Okay, so we name this as equation 1 and name this equation 2. It can be simplified further, but you know, just go for it. So if I take equation 2 and then minus equation 2, I minus equation 1, then you get, okay, 6 equal to 10q minus 4. Then 10q is equal to 10. Then q is 1. That's the answer. In question number 11. Wow, okay, it's a little bit big here to be shown on my screen. Diagram 11a. Diagram 11a shows the curve y equal to 4x squared minus 2. Diagram 11b shows the straight line graph obtained when that equation before, that curve, is expressed in the linear form. Y equal to 2x plus 4. Okay. Then what is the question? Express x and y in terms of x and y. Find the value of k. Okay, this question is a little bit different than the normal question that we normally see, because if you've seen the typical question of transformation like this, when you want to state a curve into a linear form and you transform it. Normally we will be asked to transform from a curve, from a non-linear to become linear. But this one, you have given the non-linear equation and you have already given a linear equation, and then they are asking us to find out how it was transformed. Okay, this is like a reverse engineering. It's a little bit tricky. Let me just move this to a different paper. Okay, so this is the one. Move it here. Alright, and the question is, it is a little bit too big. Again. Okay, here it is. So how are we gonna do this? Let me see. We're gonna need to do some guessing here. What is the equation again? Y equal to what? Y equal to 4x squared minus 2. 4x squared minus 2. Then we transform it to become y 2x minus plus 4. Capital Y equal to what was that? Minus 2x plus 4. Okay, this will take some time to go and burn my intellectual calorie. How do you do that? Well, normally if you're being asked to transform it, okay, from this equation, 4x squared minus 2, then we'll normally assign like, let y, capital Y become y, and then let capital X become x squared become capital X. Then we know how to do it, right? Then we know how to transform it. It become y equal to 4x minus 2. But this is different. Take a look at these two. This is slightly different. So how are we going to do that? And notice that even the gradient of these two lines are different. Notice this is 4 and this is minus 2. So how did that happen? Yeah. But let's take a look closer at these two equations, shall we? There are two things that remain consistent. First, minus 2 here and minus 2 there is the same, and 4 and 4 here. Perhaps there's a clue. Okay, let me see. I'm gonna put these two equations again just to give me some clue. 4x squared minus 2, and then I'm gonna switch side. 4, maybe you will know, minus 2x. Maybe it can give me some clue. Okay, then perhaps there's something here to work on. I think I see the light of the day. Take a look at that. So now 4, there used to be an x squared there, then now there isn't. So perhaps okay, perhaps x is equal to 1 over x squared. So if you transform it, and then it will become, well, let me write over here, y to 4x squared minus 2. If I were to transform using this, then this will become 4, and this will become 2 over, hold on, multiply. Oh yeah, if I were to divide this with x squared, then this become y over x squared. Okay, so that is something. Alright, I think we've got the answer already. Okay, let's do this. Let's do it properly. Do I just leave this thing unerased so that you can take a look at some of my thinking process. Let's do it properly. 4x squared minus 2 and transform into y to minus 2x plus 4. So let's put up, rearrange, becomes y equal to 4 minus 2x. Yes, okay. Now I call this 1. Okay, I call that 1. So divide 1 by x squared. So I get y over x squared equal to 4 minus 2 x squared. Okay, now I can transform already. Then let x, let x become 1 over x2. 1 over x2. Yes, and then let y, and then let y become y over x squared. Then you get it, right? Then you get it. Y equal to 4 minus 2x. Right, okay. So that means y is equal to y over x squared and x is equal to 1 over x squared. So this is the answer. Cool. Okay, easy stuff. But if you manage to go and really understand, analyze the situation, analyze the equation, strategize it, and see any patterns emerging from the equation, then you can probably get some answers to that problems. So let's take a look at the second part of the question. This is A, and this is A. So let's take a look at B. It's asking us to find value of K from there. Let me just put it here so that I can take a look at the chart. Value of K. Okay, y is equal to 2x minus 2x plus 4. Okay, and the gradient of the curve, the gradient of the graph, gradient m. Gradient m is minus 2. So what is the gradient here? This point here is 0, 4, and this point here is k0. So m, formula for gradient is y2 minus y1, x2 minus x1, and this is m. So in this context, space. Let's give the 4 as a y2. 4 minus 0 over of that 0 minus k becomes minus 2. Okay, and then 4 is equal to 2k. So k is equal to 2. There you go. There you get it. Okay, the video is already more than 19 minutes, so I'm gonna conclude this part 3 of video. We'll see you again in the next question in part 4 of the video. Okay, see you. Assalamualaikum.